Good afternoon, students. This is SP Smart School Learning Program. The subject is chemistry. In this video, we are going to discuss the types of chemical reaction. So, depending upon the nature of the reaction, the chemical reaction has been broadly classified into 7 types. So, our first type is the combination reaction. So, in combination reaction, two or more reactants combine together to form a single product. So, the combination reaction is the reaction in which two or more elements or compound or element and a compound combine together to form a single compound is called as the combination reaction. Next, we will discuss the types of combination reaction. So, depending upon the combination of the reactants, we have classified into three types. So, first type is the combination between the two elements. So, those reaction in which the two elements combine together to form a single product are the combination reactions between two elements. For example, let us take one example. When hydrogen reacts with oxygen, what we get is water. So here hydrogen and oxygen are the elements and we get a single compound as the output. Next type is the combination can be between the two compounds. For example, calcium oxide when reacts with water, what we get is calcium hydroxide. To understand this, let us take one activity. In this activity, we have taken the calcium oxide and water in the beaker. When these two products combine, what we get is calcium hydroxide. So, a single product is formed when two compounds are combined together. Now, this solution of slaked lime is used to produce the reaction that is used for whitewashing the walls. So, the calcium hydroxide reacts with the carbon dioxide in the room, and what we get is calcium carbonate and water. So the water is evaporated after 2 or 3 days and what we get is the calcium carbonate on the walls. So we get shiny white walls after 2 or 3 days. Next type we have is the combination between an element and a compound. So in this combination reaction we are taking one compound and one element. So when one compound and element combine to form a single product is called as combination between an element and a compound. Let us take one example. When carbon monoxide reacts with oxygen, what we get is carbon dioxide as a single product. Next type we have is the decomposition reaction. So in decomposition reaction, one single products break down into two or more products is called as decomposition reaction. Here A and B are the reactants and A and B splits into two compounds. So this is the new product that we get. So the decomposition is exactly opposite to the combination reaction. So in combination reaction, we combine two or more substances to get a single product, but in decomposition reaction, one single substance is divided into two or more substances. So for the decomposition, we require energy for the decomposition. So when we use heat energy to decompose the product, then the decomposition reaction is called as thermal decomposition reaction. For example, ferrous sulfate heptahydrate. When heated, what we get is ferrous sulfate, anhydrous, and the 7 molecules of water is detached from the reactant. Let us take one activity to understand the thermal decomposition again. In this, we are taking the ferrous sulfate in the test tube and we are heating the test tube which contains the ferrous sulfate. So, first the ferrous sulfate is green in color. When it heated, it is break down into ferric oxide, sulfur dioxide and sulfur trioxide. And the color of the ferric oxide becomes reddish brown after heating. So there is a change in a color from green to reddish brown, which indicates that the chemical reaction has taken place. Some more examples of decomposition reactions are when calcium carbonate is heated, we get calcium oxide and carbon dioxide. Similarly, when zinc carbonate is heated, what we get is zinc oxide and carbon dioxide as a product. Next energy we can use for decomposition is the electricity. So when we use electricity to decompose the reaction is called as electrolytic decomposition reaction or electrolysis. So most common example is water. When water electricity is passed through the water, what we get is hydrogen and oxygen. So it is clear from the reaction that the hydrogen we get is twice the amount of oxygen gas. Next energy we use for the decomposition is sunlight. So that decomposition reaction is called as photo decomposition reaction. So photo means light. In this reaction we are using sunlight to decompose one substance into two or more substances. So to discuss this we are taking one activity. In this activity we are taking a bowl in which we have taken silver chloride. So silver chloride is kept outside in the sunlight. So the silver chloride breaks down into silver and chlorine gases evolve. So the decomposition reactions are endothermic in nature. It is opposite to combination reaction. Simply we can see the examples of decomposition reaction is the breakdown of starch into smaller substances and protein into amino acids when the digestion of food take place. It also helps in the extraction of metal. Next type we are going to discuss is the displacement reaction. So in displacement reaction, more active element replaces the less reactive element from its compound. So this reaction is between an element and a compound. So understand the displacement reaction. Let us discuss one activity. In this activity, we have taken a test tube which contains copper sulfate solution. In this copper sulfate solution, we have dipped the iron nails. So the iron nails are kept dipped in copper sulfate solution for 20 minutes and more. When we take out the nails, we have found that the iron nail has converted into reddish brown color when compared, and the copper sulfate solution faded, as you can see in the figure. Now let us see the chemical reaction. Where iron reacts with copper sulfate, the ferrous sulfate is formed and copper is displaced by the iron. So the copper is displaced by the iron. Why this happens? Because the iron is more reactive than copper, so it displaces the copper from its solution, that is copper sulfate, and the new solution is formed, that is iron sulfate. And at the end, the copper is displaced by the iron. So the color of the copper sulfate solution faded. Similar examples of the displacement reactions are when zinc combines with H2SO4, we get zinc sulfate and hydrogen is displaced by the zinc. Similarly, when zinc and copper sulfate solution are added, what we get is zinc sulfate and copper is displaced by the zinc. Why? Because zinc is more reactive than copper. So the zinc replaces the copper from the reaction. So this is the reactivity series of the metal. The potassium is highly reactive and the gold is least reactive. Similarly, for the non-metal, the fluorine is highly reactive and the phosphorus is least reactive element. Next type we have is the double displacement reaction. So, in this reaction, the exchange of ions take place. That reaction is known as double displacement reaction. To understand this, let us take one example. In this activity, we have taken two solutions. So, in this test tube, we have taken barium chloride and in this test tube, we have taken sodium sulfate. So, when the sodium sulfate reacts with barium sulfate, what we get is barium sulfate and sodium chloride. So, the sodium sulfate reacted with barium chloride, what we get is barium sulfate and sodium chloride. So, there is the exchange of ion between the compounds and new compounds are formed. Next type we have is the precipitation reaction. So, what is the precipitation reaction? The reaction in which two reactants combine to form a solid which is insoluble in solution. That reaction is called as precipitation reaction. So, let us discuss the activity. In this activity, we have taken the lead nitrate solution. So, when the lead nitrate solution is added with potassium iodide, both are colorless. So, when these two are added, what we get is lead iodide solution. So, a yellow precipitate forms and settled at the bottom. These are of yellow color. So, this is the reaction in which the precipitate is formed. One more example is when calcium hydroxide reacts with the carbon dioxide of the room, what we get is calcium carbonate and water. So the water is evaporated 2 or 3 days after, and what we get is the precipitates of calcium carbonates on the wall, which gives shiny white color on the walls. So let us discuss one question. In this question, we have to tell the name of the substance which is used for whitewashing, and we have to write the chemical reaction as well. So the substance used for whitewashing is the calcium oxide. So the common name for the calcium oxide is quicklime. When quicklime reacts with water, what we get is calcium hydroxide. Okay. When calcium hydroxide reacts with the carbon dioxide present in the environment, we get calcium carbonate, which is the end product after 2 or 3 days. This calcium carbonate forms a hard coating on the wall. So we get shiny white walls after 2 or 3 days when the water is evaporated from the walls. So the chemical reaction for this is when quicklime reacts with water, what we get is calcium hydroxide. And when this calcium hydroxide reacts with the carbon dioxide in the room, what we get is calcium carbonate and water. And water is evaporated after 2 or 3 days. So what we get is calcium carbonate on the walls. Next we will discuss is the neutralization reaction. So a reaction in which acid and base react to form salt and water is called as neutralization reaction. Let us discuss the examples of neutralization reaction. When sodium hydroxide, that is base, when reacts with HCl, that is acid, what we get is NaCl, that is salt, and water is released. So in neutralization reaction, what we get is base reacts with acid to form salt and water. So last is oxidation and reduction. We will discuss in the next video.